Hello and welcome to the video. This is a quick video on some of the common mistakes that I'm seeing pilots make with INAV. Now I use INAV on both fixed wing and multi-rotors. This is the Recon 7. I did a video recently on converting this from Betaflight to INAV, and I can do that because not only does it have a GPS, it also has a compass and it has a barometer too. So I can use all the INAV flight modes, including all the GPS navigation stuff. The return to home works beautifully. It is great. I also use it on a lot of fixed wings too. The most recent one that I put it in is this thing here. This is the Alpha Strike from ZOHD. Again, I did a video on that. There's a link below to it. There was a couple of tricks to getting this set up and flying really well, both in manual and INAV. And I've kind of documented all that stuff and put it in that video. Again, link below if you're interested in. But what I'm finding is that at the moment, INAV 3.0 has been out for a little while. The documentation is really struggling to catch up with this stuff. And whereas historically, just by reading the documentation, you would finish kind of a reading session and go, okay, I know what I need to do. It isn't that clear anymore because some of the documentation is still out of whack. So I thought what I will do is let me put together the top 5 mistakes and problems that I'm seeing people bump into when they're setting up INAV that's causing them grief, and hopefully it'll help you out. Mistake 1 is trying to arm your multi-rotor in something like a GPS mode, like GPS position hold or GPS return to home. It won't arm. Now the cool thing is, if you're running with FPV, or even if you have something like the INAV Lua script on your radio, if you try and arm, INAV will try and tell you why it's not happy and why it will not arm. The FPV stuff, to be honest, is the best way to do it. If you're ever at the field and you flick the arm switch and it just beeps at you and basically says, I'm not going to play, the best thing to do is just look in the goggles and it'll tell you exactly what the issue is. I had an issue recently where in the latest version of INAV, you can set the waypoints to be loaded automatically. The issue is, as of the recording of this, the way that works then is that even if the mission isn't going to be flown, you're not going to be using the auto flight mode, and the mission is too far away, the copter won't arm. But again, it will tell you in the on-screen display, in the messages part of the OSD, exactly what the issue is. So the trick is here is you don't arm in GPS position hold, you don't arm in GPS return to home or auto, you don't use any of those. The way I would recommend you do it is that you have something like Horizon as the first mode that you arm in and then start to fly, and then have the other modes available that you can flick into. Once it's flying, you can turn into nav position hold, which will hold it in 3D space, both in forwards to backwards, left to right and up to down. It will wander a little bit, but we'll come more onto that in a minute. And then when you're ready to land, I particularly would pop it back into Horizon to land as well. And that used to be a little bit clearer in the documentation. It's not at the moment, and I struggled to find an example to show you where it is in the docs. I'm sure it's probably in there, I just couldn't find it when I looked. Problem 2 occasionally is the fact that when you put it into something called altitude hold, the throttle response feels sluggish. And that's exactly what you'd expect. This is covered, if you look at what it says in the documentation, for altitude hold. It can change the way that the throttle works. So rather than directly controlling the speed and power of the motors to control whether it's sinking or rising, when you're in altitude hold, it works in a completely different way. It probably means that you've missed that in the documentation, but there are different ways that you can set it up to have it work. But that also means that in some of the more sophisticated modes, the throttle is going to behave that same way too by default. So be aware of that and be ready for it. When it's at altitude hold, it's actually going to sit at that level. Increasing the throttle will make the model rise in the air. Decreasing it below that point will make it sink. And where that point of throttle is for I'm going to hover here can be set in INAV. Mistake 3 is about fixed wing. Now, there is an auto-tune feature in fixed wing that allows you to fly it, and in INAV 3.0 it's very clever. Not only does it work out the PI and FF rates, because it's not PIDs on a fixed wing in INAV, it's PIF, proportional, integral and feed forward. It'll also figure out the rates, how fast you can make the model move and fly around. Unfortunately, to be able to do that, it needs to be in ACRO mode to fly it. So you need to get up in the air, you need to put it in ACRO mode, and you need to fly it around. Now, in previous versions of INAV, you could use auto-tune with a self-level mode, and that was much easier for newer pilots because they always had that ability to let go of the sticks, and horizon or angle would level the plane out. So if it was all getting a bit squirrely, they had that fallback position. Unfortunately, in INAV 3.0, I think it needs to be in ACRO mode, which means you have to know what you're doing and be able to fly the plane in order to tune it. Hopefully the ability to change that and the documentation catches up a little bit. You can change auto-tune to not calculate the rates. Maybe if that's the condition, you could use it in one of the auto level modes. Not sure, I haven't tested it. Hopefully that's all going to be cleared up. But as it stands right now, if you're going to auto-tune a fixed wing model in INAV 3.0, one of the modes has to be in ACRO, and just like I showed in this video, you go into ACRO first, then you start the tuning process. The other cool thing about it is that you used to have to save the PID settings down to the flight controller. These days it doesn't seem to need that. It seems to be saved when you finish your flight and disarmed. So number 4 is one that I see a lot, and INAV is very particular about making sure the accelerometer is calibrated properly, the compass is calibrated properly too, the baro is working beautifully, and the GPS is as well. All of the sensors in here have to be working and be calibrated very nicely in order for all the flight modes to work. If they're not, you know what, you'll get some weird stuff happening. So the way I commission a model is kind of the safest way, in my humble opinion. I've been doing it this way for 5 or 6 years with INAV. So first thing you do, I would set up 3 flight modes on your model. Well, let's talk about a multi-rotor for this example, because this is the one that tends to catch people out. Horizon is my basic mode. That allows me to arm the model, because again, you can't arm the model in a GPS mode. We see previous point. Take it off and hover about and just do the usual stuff. Make sure that you know, it all responds the same way, that it's pretty stable in the air, that it's not sliding off to one side or the other. If it is, go and recalibrate the accelerometer. And once I'm happy with that, then I'll flick it into the GPS position hold. Now, position hold actually uses pretty much all the sensors. It's going to use the GPS for location, it's going to use the GPS and barometer for height information, it's going to use the compass for which direction it's actually pointing in, which it needs to know if it's hovering in order to maintain its position. This is why we don't have position hold in Betaflight, because Betaflight doesn't care about compasses. And you need all these pieces working. So by putting it into position hold and having it kind of gently wander about the point that you initiated it at about the right height, confirms to you that everything is working. The biggest problem that I find is the compass isn't calibrated well enough. If you find that it starts doing something called toilet bowling, which is like that, which is where it kind of looks like it's spinning around the outside of the toilet after you've flushed it, that is almost always a bad compass calibration. If position hold works, then I will fly it further away. Always do this line of sight. Make sure your spotter is on the ball and is had his coffee that morning. When it's far enough away, hit return to home. Be ready at any point during this to be able to initialize the horizon mode and fly it back to you. But when return to home is activated, it's going to use all the same sensors as position hold, but then it will rise to the altitude that you set and it'll fly back to you, hover, land, descend, and then disarm. That is the basic test to make sure that INAV is set up properly. If any of those things don't work flawlessly, you know what, you kind of need to go back and check the accelerometer calibration, compass calibration, make sure the barrow isn't in airflow and getting lots of breezes over it, which will be read as a change in altitude. I would also perform those checks at the field. When you are going to be flying INAV and you're going to be using potentially one of the mission flying capabilities, or you're going to be using GPS return to home, or you're flying in a new location and you're not sure you know, how you're going to get on, you want to pretty much guarantee that return to home is going to work for you, I would do that test first. That also means that if you find it isn't working, you can do the compass calibration at the field before you go out and fly. The final mistake is one that I see because historically in INAV you used to have to turn lots of different flight modes on. So going back to the last one I was talking about, where position hold is using the barometer and the GPS for not only 2D positioning but actually the height as well for full 3D positioning. So actually when you initiate a nav position hold, you're actually turning on lots of other modes as well. It is covered in the wiki, but I've seen pilots that historically have used older versions of INAV actually turn on all those things separately. You don't need to. If you just turn on nav position hold, that will automatically enable nav altitude hold so it can sit in 3D space. So have a look at that table in the documentation. Hopefully that will help. So stay tuned, I will be doing more videos on INAV 3.0, setting it up on both the multi-rotor and inside a fixed wing, and go through the tips and tricks that I have for maidening and making sure that it works flawlessly. A lot of the information that I've talked about in this video is not new to the channel, it exists in other places, but what I wanted to do was kind of bring it together to hopefully stop some of the pilots out there that are getting into trouble, avoid some of the common pitfalls that I've been seeing a lot recently. Best of luck with your INAV build. Stay tuned, there is more INAV 3 content coming. Thank you for spending your time today watching that video. You can find me in all the usual places on social media, and if you're trying to learn about a subject, then check out the playlist. All of my videos are organised into easy to follow playlists that if you're trying to learn a topic will take you from the basics right the way through to some pretty advanced stuff.